Hello class, this is a video tutorial on the introduction to rates and the unitary rate. To compare ratios, compare parts of a whole to each other. It can also be seen as comparing values of the same measurements or the same units. So these two examples show a ratio. Here we have a class of 20 students and we divide them to boys and girls 14 to 16. So in this case, boys is to girls, and we write this as 14 is to 16. In this example, the measurement or the unit, it's 14 people and 6 people. So we're measuring people to people. So it's the same unit or the same measurement. In this example here, we have a person's income of $600 and we're dividing it into savings and expenditures. So we write this as saving is to expenditures, 400 is to 600. And once again, notice how the dollars is the same measurement or unit we are comparing to. It's just that we're dividing it into different parts of the whole. Rates, however, compare values of different units or different measurements. So straight away, this first example, we can see that a car traveled 150 kilometers in 2.5 hours. So notice how we have kilometers and hours. These are different units of measurement. To write this, we no longer use the ratio symbol. We write this as 150 kilometers. You can either be as per, this is the preferred one, per 2.5 hours. You might also see this as 150 kilometers over 2.5 hours, but that's just what this fraction is symbolizing. When it comes to rates, the order of these can actually change. It can be 2.5 hours per 150 kilometers. But if you're familiar with rates that we use in the real world, the order of these, one is more used than the other. In this instance, time is almost always the per unit, so per time. So here we have a rate. Here's another one. 3.75 kilograms of beef was bought for $84. Once again, we're comparing kilograms to dollars. So we could write this as 3.75 kilograms per $84. Or we can switch the units around. $84 per 3.75 kilograms. And once again, you can probably figure out that one of these orders is more used in the real world. It's actually this one. The next one, a tree grew 765 centimeters over 90 days. Okay, so again, we can write this as 765 centimeters per 90 days. Or we could change the order around 90 days per 765 centimeters. Once again, can you figure out which one is more used in the real world? Yeah, in this case, it'll be this one. So while we can write the order of rates in any order we like, some orders are more used than others. Here's another. Scientists observed 62 bears living in a region of 3.4 kilometer square. And in this one, we could write this as 62 bears per 34 kilometers squared, or we could change this the other way around. But I'm going to go straight away into this this order because this would be the correct one. So notice how we have the rates. Rates are a comparison of two different types of measurements. Now, just as ratios can be simplified, rates can be fully simplified to what's known as a unitary rate, which always expresses a rate as some measurement per 1 unit. Now to do that, since we have this as our rate, we want to change this to per 1 hour. Well, in order for 2.5 to become 1, you can think of this as drawing an arrow. We are dividing by 2.5. But since we divided this rate, this portion of the rate by 2.5, we do the same to the other units. So we go 150 divide 2.5. That gives us 60 kilometers per hour. Oops, let's write that in. And that is the unitary rate of this original rate given. Let's do another. Same deal. We want to bring this down to per 1 kilogram. So we want this 3.75 to become 1. Well, that's just simply dividing by 3.75. And we do the same to the other side of the rate. So 84 divide 3.75. That gives us $22.4. So $22.40 per 1 kilogram. Okay, so here we go. Let's do the next. From here, we want to bring this down to 1 day. And for this, we are dividing by 90. So we do the same on the left side of this ratio. We divide 90. So 765 divide 90. Divide 90. Let's try that again. 765 divide 90. Let's see if it works. There we go. We get 8.5 centimeters per day. And for the last example, we can bring this down to per 1 kilometer squared. So we do 62, 16 kilometers squared, sorry. To do that, we divide this by 34, and we do the same to this side. Divide 34. So 62 divide 34. 34. We get 1.82 bears per 1 kilometer squared. So that is unitary rates. Hope that's giving you an insight into how they operate. I hope to see you in the next video, and we'll do some more examples then. Hope to see you then, and best of luck.